Okay, so this is practical application number 8 in chapter 4 of the Advanced GIS textbook. This is the second video tutorial of chapter 4, and it's about mapping environmental justice using social vulnerability indicators and as well as features related to environmental justice or environmental hazards such as pollution. And so in this video tutorial, I'm actually going to look at looking at a relationship between different aspects of social vulnerability and natural hazards in Utah. But in Lab 4, you will look at environmental hazards as monitored by the Environmental Protection Agency, looking at toxic release facilities. And there was previous to this current administration, a really excellent website created by the Environmental Protection Agency called EJ Screen, or Environmental Justice Screen. And fortunately, that website has been mirrored by several groups. And so we're looking at what that EJ Screen website looked like. And for the entire conterminous lower 48 states right now, I've got up ozone levels across different counties. Maybe it's block groups in the US. Actually, it is block groups. It's just they get big as you zoom out. And so we can see areas with high ozone, especially Central Valley of California. But in Utah, there's pretty high ozone areas in certain parts of our urban front as well, especially in the lower parts of the valleys down near Great Salt Lake, and down on the lower part of the south east valley of Utah Valley. And so this an EJ Screen tool was really basically democratizing GIS data about environmental pollution hazards for the people to see. And so it's really it was an excellent tool created by the government and taken down by the government. But fortunately, that work was not lost as it's been mirrored by several groups. So you can navigate around to look at different types of pollutant, so air particulate matter, and where that, on average is worse. And then you can bring in other things like demographic factors. So where people of color exist, where low-income people exist, etc. So people of color, do I have that up? Let's see. Yeah. If I look at low income, it's a little different. And so in this tutorial and in your lab, what we're going to do is create some similar sorts of geographic analyses using census block group data and using environmental justice indicator data related to EPA toxic release facilities using buffers. We can't use the EJ Screen data directly. If here we're visualizing it, how do you get a hold of that? It was fairly easy to do on the EPA's website. I think you can get it through this archived data tool here that I basically got to by clicking on some of their links in that mirrored site, but it's not exactly clear to me. For your lab, I previously downloaded it from the EJ Screen website, and it's provided to you. But for the video tutorial purposes, I wanted to kind of go back to the original Census Bureau tables and Tiger line GIS files, so you can see how you could create your own custom tables to look at socioeconomic factors, and not just for environmental justice analyses, but you could do all sorts of different things with them. Okay, so I'm going to close this website. Where am I getting to these from? So if you go in the book, I've got link to the Census Tiger geographies and Census tables within the book chapter. So here's a census table. And in this tab, I've got open the census data tiger line shape files. And so what I'm going to be downloading is called American Community Survey data, and I'm going to download it from 2023. And so remember that small census geographies, such as block groups, can change with time. They're kind of redrawn following each decennial census prior to the next one. And so, we could probably download the 2023 American Community Survey estimate data, ACS data, and append it to 2020 block group data. Still, that would probably work, but I'm going to go ahead and, for this tutorial, download the line shape files for 2023. And so what I would do is I would go to the web interface, is probably the easiest way. I want to go to the year I'm after, and I'm going to be downloading block groups. Okay. And then I would go to my state of Utah, and then it's downloaded them for me as a zip file. Now you could go about it this other way, you know, but FTP archive by state, etc. But then, you go into the state and it's like, okay, which of those is my county? I don't know. You could look it up probably. Yeah, I guess we can. And actually, in our textbook, there it tells us Utah County is, well, 49 is the state, and then 049 is Utah County. So the one I would want would be here, and then actually that's different. That's area of water, feature names. That's not what I wanted. I'm in the wrong group. I want to go to the FTP archive here. Then yeah, so the FTP archive is a little bit trickier, right? Because you need to kind of, BG is probably block group. And then, okay, this appears to be by state. So we would go to 49, that's Utah, download it. So yeah, those are the ways that you would get at your Tiger Line files. And, basically GIS files, topologically, I'm forgetting the acronym, but I've got it written in the book here. So they're called Topologically Integrated Geographic Encoding and Referencing System. That's what TIGER stands for. So that's developed by the Census, and that's how they organize everything. Okay, so then what can you do with that data? So we've downloaded the block group data, and I'll show you this in a secondary block tutorial, video tutorial. But what can we do with it? We can basically take those block group features that we're going to load into ArcGIS Pro, and it's going to have a reference attribute, either called GeoID or FIPS, Federal Information Processing System, FIPS. That's basically a unique code which relates to, it's this code right here. It has the state, so it's a code related to the geographic entity that you're looking at. So in the case of block groups, state, county, tract, and the number of the block group. So that's this block group right here for where Utah Valley University is located is that number. And so it's basically showing you the census hierarchy data, but it's a unique code that we can then append data to. And we can get that from the Census Bureau tables. And so what we do is we're like, okay, I want to get block group data, right? So we're in this is this Census Bureau tables download interface. It's also a visualization interface. You can click on maps and pull up whatever you're looking at. So it's quite dynamic and good, but it is a little bit obtuse for downloading things and getting them in a format that you can bring them into your own GIS is not the most straightforward. So I'm going to show that briefly here. Okay, so block groups for Utah, and then you can go by county, and you could say, I want all the block groups in that county. Okay, so, and then after that, you can say, well, what do I want to show? There's actually so many things, right? There are, yeah, you can see like right here, I've got 10 results. There's more than 10 pages of these results. So hundreds of collected census data about business and economy, education, employment, government, health, etc., income and poverty, people, race and ethnicity. And so to download these tables takes some time. And each one of the tables has a lot of things. And so briefly in this video tutorial, basically, I'm going to show you what you could do to begin to get kind of custom tables that you could utilize. So I'm interested in social vulnerability. I want to know about people, who's there in terms of race and ethnicity, age of people, gender, um, income, poverty level, education level, things like that. And so if you're interested in education, you click on that and then you're like, okay, I want to know about educational attainment. And then it's like uh, education attainment for the population over 25 years, Americans Community Survey data, click on that. And I want it for 2023 5-year data tables. So I guess it's already loaded. So here it is. And this is the way it looks. So this is a block group 1 within census tract so-and-so in Utah County. Okay. And so it gives you the estimate. So no schooling completed for 592 people in that block group. Maybe that's because there's a bunch of kids, plus or minus 200. So pretty significant margin of error on their regular high school diploma. Nobody's got a doctoral degree, master's degree, some bachelor's, etc. Yeah, so this you could imagine won't pull into your GIS very easily because the block group should be on this axis and the data should be on the top axis. And you can, transpose how this looks. So now we've got it kind of in the right order, right? Where the information about the block group is on the top and the block groups are on the sides. But how do you get at this? Well, also um, you could not show the margin of error. So it makes it simpler. But what you do is you download it. And if you download it as a table view format, it's going to be pretty challenging for you to pull that into GIS. What you want to do is this one right here, zip file, flat, machine readable CSV files, which includes GeoIDs, which you'll be able to link to those features. So you click that, you click download, you tell it what estimate year you want. I know that 2023 was the last 5-year data. You click download. And actually, it did download it. First, it like prepares the data table. It's supposed to trigger a download. It did for me, but watch that because when I was doing this before, it was preparing the download, it wasn't triggering it. So then I had to click download the file again, and then it would work. Okay, so be cautious of that. Okay, so I did that for a number of things as zip files. And so I'll just show you that briefly in my file structure here. Computer's being fairly slow. Apologies about that. So in the book for chapter 4, examples, Census, so you can see the zip files and the extracted data within there. So in each zip file, um, there's column metadata, so you can get detailed data about each of the codes in each column and what they mean. The original data, CSV, and you also get it as an XLS file. I think that's true. No, that's because I saved mine as an XLS. So you get a CSV of the metadata, CSV of the data, and then notes in a text format. So there's a bunch of metadata, 2 files about that, and the actual data. I have the file that I have open is the one here, which has this XLS, American ACS American Community Survey 5-year estimate 2023 B01001 is this code for what table I have opened. If you want to know what that is, we need to click on the notes probably. And it's not so easy to read all these things, but there is some information there. If I go to the metadata CSV, it might be even easier. And so basically what I've got in this file is a GeoID, which is the geography of the block group. There's a name, estimate of population. See, it's not even that easy to tell what it is, right? So you have to be pretty careful about your file structure and naming and know what you've got here. So what it's showing me is total people, margin of error, total number of males, margin of error, males under 5, etc. And then it has females as well, like that. And these weird codes are how it's listed in the table. So let me show you that. So when you download it, it looks like this. So here's my GeoID, and one of these right here would be what I wanted to say preserve to like append to the feature class of the block group in ArcGIS Pro. And then it's like a huge table, right? And so the top row is kind of codes. The second row is basically the information that you need as the headers in your file, in your GIS, and then the data is after that. But you don't want to bring in all of this data into your analysis. It's so much. And so what I've been doing is cleaning things up a bit. So first thing I did was, well, not the first thing I did, but eventually I got rid of the first row because I didn't need it anymore. And I replaced the second row with more understandable codes for me. So now it's like I called the first thing the FIPS GeoID right here. And then I've got, after that, pop estimate, not just total estimate. I got rid of all of the margins of errors information. Now that's, of course, not maybe the wisest thing to do if you're going to eventually publish the result, but just for ease of dealing with the initial analysis, I decided to do that. And so basically I highlighted every other column, right click, and delete those margin of error estimates. And then I went through and I renamed it population estimate of total of males, males under 5, males 5 to 9, etc. Same thing for females over here on the right as we go. For my analysis of social vulnerability, I don't need all this either. And so what I want to do is this. So I'm going to insert some new rows, and I'm going to now say, I want to know for our like social vulnerability, we kind of really want things to be in a similar format. So percent or ratio would be better than just raw numbers, since there's so much variability in the raw numbers that you can see here. Some blocks groups have only 755 people, and then others have over 3,000. So it'd be better to have like a percent of males under 5, right? But I don't even want that much detail. The census is collecting all these details so they can model maybe um, needs for school funding, needs to meet Social Security demand, etc. And so they got these really kind of fine demarcation of age. But I really maybe want like is percent male working age, right? And so to get that, we'd then do some math. We could equal all the males that are working age might be like these ones. So until age 65, say, and then divide that by total estimate of males. And what does that give us? Like that. In like that format. Let me do that a little differently. So I'm going to do equals sum of these ones. Oop, didn't do that right. Let's write this. Equals sum of 18 through 65, and then divide by total. Okay, so 64% of the males in that block group are working age, right? So that might be a useful metric for social vulnerability. I might want also same thing, percent female working age. Then I would do equals some, and I got to go over here. Then divided by the total number of females. And so a bit more of the percent of the females in this block group are of working age, right? And so those were useful ones, so I can like copy that formula down, right? So it's going to do that for each of those. Now I can do percent male young dependent young. Okay, so these are like school aged and younger. So then I would say equals sum of under 5 to 16 to 17 divided by that one. So a lot of young people. Not too surprising, I guess. So that comes to, yes, we're going to not get very many old people. So then I can copy that down, and it'll be the same percent male, no, female, dependent, young, equals sum here of these ones divided by female total estimate. In that block group, less female, young. Okay, and then I could do, okay, now let's get percent male dependent old. Now, this is just an estimate, right? Because many people over 65 are still quite independent and actually contributing to society in really important economical ways, right? So you could adjust this, right? Maybe you're only interested in, maybe you could have done the working age till 70 or 75 even if you wanted, and then move this dependent old to over 75. But I'm just doing an estimate based upon traditional kind of numbers here. So equals sum of those over 65, whoops. So 65 to over 85, and then divide that by estimate total. It's not very many old people in that block group, but this next one has way more, right? So we'll be able to see those differences as we map them. So where are older generations? Where are they not? Right? There may be some block groups with a lot of over 55 communities and others with, mostly only young children. So now we do percent female underscore dependent old equals some, scroll over. Now we could have done all of these kind of things of table modification in ArcGIS as well. Probably not the best way to go about it though, because it's really challenging to see many rows and columns in ArcGIS Pro. I think it's easier to deal with in Excel. It's probably, if you really know these tables well, obviously this workflow could be probably made even easier if you use something like R and some more coding to do this a little bit quicker. But especially for this video tutorial and my own skill set, I find this easier and understandable so you can see what I've been doing, right? And so I might, these are, I say percentages, but they're really ratios. If you multiply by 100, they're percentages, but I left them in ratio format. And so what I've got here is working age males and females, young dependents and old dependents. Now, and they're divided by gender. Maybe gender is irrelevant to my analysis. So if that's true, then maybe I should have done this differently, right? I should have done percent working age. And then I should have just done equals sum of these. I'm going to go all the way just to 70 for this example. So that's for males plus the sum of the females of that same age. So 18 to 70. And then I'm going to need some parentheses around that. And I divide that by the addition of total females plus total males. Or I could have done it, sorry. They've already got that for me here, population estimate, right? And then, so that gives me percent working age, higher number because I went up to 70 till 65 instead of 65. And so that's why that number is quite different than C and D over here. And so as you're doing this kind of table modification, you need to think about things like that. Do you really care about different genders in terms of their working age, dependent age? Probably not. It doesn't matter, right, if a young dependent is female or male in terms of social vulnerability to an environmental hazard like air pollution, right? Both are just as important. So we could probably aggregate even more, right? And then so we get rid of the gender aspect here. Now, if you wanted to know how, if your research was kind of a gender study analysis, then you wouldn't do that. You would leave it in those separated genders. But you can aggregate it if you want in this table, and that gives you less total variables to input from this table. But remember, this is just looking at age and number of people or percentages of people of those ages in the block group. We're also going to look at other things like percentages of different ethnicities and races. We'll look at percentage of well-off people, impoverished people, and so other things. And so we'll get quite a few census variables that we're going to input into a principal component analysis in this process. And so I think it's okay to kind of, if you know, get a big table like this, to reduce it down to, in this case, it would end up being like 3 variables coming out of the age and dependency related to age for the census data. So hopefully you can see how that would work. And then what I would end up doing probably to bring this data as a table into ArcGIS would be to create a new sheet. I would take, I would take the data that I'm interested in and say if I wanted all these things, so instead I said I wanted those 6, so I kept it by gender. I'd bring those over here. I gotta be careful here. So I need to also get these things because I need the GeoID, right? So that's why I put them right here rather than at the end of the table, because I'm going to want all of these things. And I left the population estimate here, so you could potentially in GIS, you could turn that into a raw number afterwards by multiplying by that. So it's a good idea to leave that population estimate in there, but don't feed that into your PCA analysis when you're working with these ratio numbers. That's different units. So I copy that, and then I paste it here as values, and then that's the table that I would bring into ArcGIS Pro. It's simpler, right? We only have 1, 2, 3, 4, 5, 6, 7, 8 columns to bring into our table. That's manageable. We might bring in, 4 to 8 columns from each of the tables that we're going to bring off the American Community Survey. In the end, we'll end up with a huge feature class attribute table. And so, yeah, it's a good idea to trim what you're bringing in. So then I can say, save this as, if you just want that page just to keep things, you could save it as a CSV or a text file, and it would just save that one page or that one sheet. If you save it as an Excel, you can use that too, but you just need to navigate to the sheet where things are simple. So in this case, sheet 2, you could rename that maybe to ACS pop age, and that's what you're going to want to bring in. Okay, so yeah, this video tutorial is basically downloading census data and preparing those census tables to be brought into ArcGIS or another GIS program with a table append. And so next video, I'll demonstrate that process a bit and then going forward. Okay, so hopefully this is a good start for dealing with census data.